Hello, it's Brendan Wissinger today, and today we're going to talk about understanding the predictions, the climate prediction, predictions on climate. What's with 2030? What's with 2050? What do those dates mean? What does net zero mean? All of that type of stuff. So we're going to talk about that and talk about tipping points and positive feedback loops and that sort of thing. I'm soon going to do videos on transportation, solving climate change transportation, an overview on solving climate crisis, an overview of how to solve the climate crisis in agriculture, how to solve, and also I'm going to do ones on COVID-19 and one on the national debt. Because so I'm going to get to those in a minute. So here's your So here we go. So yeah, I added some transitions in here. So degrees. The amount of warming of climate change is recorded in degrees Celsius. Degrees Celsius as in the departure from normal temperature. So the departure from the normal average, and that these are 1, 2, 3, 4 degrees, and they may seem small, but you got to remember this is on a planetary scale. So it got to affect the entire planet. So it's they may seem small, but they're actually large changes because of the size of them. 1.5 degrees, the point of what the scientists refer as dangerous climate change in the Gulf of Paris. That's 1.5 degrees Celsius. 2 degrees, the point that set off a chain reaction of uncontrolled warming. Not Venus, but it could lead to warming that could leave some areas of the planet uninhabitable. Carbon budget, the amount of carbon left to burn for a certain target at current rates of burning fossil fuels. Net zero emissions, all emissions that are emitted in all emissions. Net zero is that all emissions that are put into the atmosphere are sequestered out of the atmosphere. And for that does require a large level of decarbonization because there's not enough plant material on Earth there's not enough plant material or plantable area. Well, I don't know if there isn't enough, but it would require an area the size of India to plant enough plants to do it, and you have to do that every single year. So there wouldn't be enough area to plant that many plants. So that's sort of not going to work. Peak emissions, the highest point of emissions. So that means the emissions from there must start going down. Positive feedback loops, natural cycles that reinforce human-caused warming. Tipping points, impacts that warn of danger and setting off positive feedback loops in the motion. And points where a subset of the climate system changes and will not naturally, and because of that will not naturally return to its prior state. So we're going to talk about positive feedback loops first. You ever heard of the term vicious cycle? That's a positive feedback loop. A positive feedback loop is a scientific term for a vicious cycle. So the climate has both positive and negative feedback loops. Positive in that they reinforce whatever is causing it, or negative is in they decrease whatever is causing it. Unfortunately, there are more positive feedback loops than negative feedback loops. So here's an example. Methane being released from permafrost. As the climate warms out, the permafrost melts in the Arctic. And as it melts, methane that was stored in the permafrost is released. Methane is a greenhouse gas, so that causes more warming. Cycle continues. Second example, reflective ice melting reveals absorbent or reflective ice. The ice is white and it's reflective to the sun's heat and light. So when it melts, it reveals dark sea, dark ground, which is more absorbent of light darker in color and ends up absorbing more heat. So this means even if we stopped emitting right now, the global warming would continue to happen for about 1.1 degrees Fahrenheit. Until 1.1 degrees Fahrenheit. Excuse me, until. So that means, yeah, it would continue to happen for about another tenth of a degree, I think. Tipping points. Points that where a subset of the climate enters a new state. Some tipping points are also positive feedback loops. So, in a tipping point, a subset of the climate enters a new state. For example, here's the Amazon rainforest. If there's a certain point where if we deforested enough, it could turn itself into savanna, because there isn't enough trees and transpiration for the be enough in the app. There wouldn't be enough transpiration for there to be enough. I'm trouble doing words. There's not enough transpiration that for the rain, because the rainforest creates the rain. There's not enough trees, not enough rain, and it turns itself into savanna. Savanna is obviously not necessarily obviously, but savanna is not as absorbent of CO2 as rainforest is, so it stops, or it doesn't sequester as much, and that hurts the climate. That would be a tipping point. That's one tipping point. You see a map on here of a bunch of different tipping points throughout the world. So that's a map of tipping points. Sometimes we know tipping points before we cross them, and sometimes we don't. So these tipping points are almost like landmines. So some of them you don't know when you cross them, and you cross them, and then you realize you've crossed them. Some of these on here are starting to already cross. For example, the calving of Pine Island Glacier, and there's some we've already crossed. Or the Amazon turning into savanna, the disappearance of summer sea ice, and the disappearance of coral reefs. Those would be considered tipping points. What's with 2030 and 2050? The IPCC's special report on 1.5 degrees gave a dire warning to have a 50% chance of staying below 1.5 degrees Celsius. A 50% chance. 50-50. For dangerous warming, we must reduce our emissions by 50% by 2030 and the net zero by 2050. Many scientists believe this is an underestimate of the danger because these projections don't take in a full account of the positive feedback loops. This is also not taking into account equity, that some countries need longer to adapt and mitigate. This is assuming also that my generation can pull millions of tons of CO2 out of the atmosphere with technologies, as Greta put it, barely exist. These technologies are still in their infancy. So, yeah. So we need to be. So this is a problem. So, yeah. That means the targets that the IPCC set are actually very conservative. Very conservative. Very conservative. This doesn't mean that the world will end in 2030 or 2050. This means if we don't get emissions down, etc., that we will lock in 1.5 degrees of warming and the impacts that I'll actually talk about later will occur. An actual good target. A good target for 1.5 degrees would be reducing emissions by 35% by 2025, 70% by 2030, and net zero by 2040. That would be a good target. A good target for 2 degrees would be a 50% reduction in emissions by 2030 to 2035, and net zero by 2060. As you can, this is a graph, and this says medium chance of staying below, of medium chance 1.5 degrees pathway. That means 50-50 chance. And you see that's in the red, and in the blue is likely 2 degrees pathways. So a likely chance means we'll most likely stay below that. So runaway climate change. Not Venus. After 2 degrees, it's not going to be like become like Venus. That's not going to happen. After 2 degrees, it would set off a series of tipping points that could make more warming inevitable to a certain point. The warming could probably rise to 4 degrees, and CO2 will stay in the atmosphere for 200 to thousands of years. So this is why we need to avoid 2 degrees, because we don't want to get any higher. That said, this part here, the warming itself would probably start to go down at some point from the positive feedback loops. It starts to reduce itself. That said, it won't go back to normal because the CO2 will still be in the atmosphere. Carbon budget. A carbon budget is the amount of carbon dioxide we can still emit without going beyond a certain degree, a certain limit. This is the number of changes based on new research. At our current emissions rate, we only have 6 to 9 years left for 1.5 degrees Celsius. 6 to 9 years. That is not long. If we used up our reserves of oil, we would already extract, or what we've already extracted would exceed our carbon budget by 5 frickin' times. That's why we need to keep fossil fuels in the ground. 5 times. It would exceed them by 5 times. If we used our reserves of oil, everything we have on stockpile, not with what we're currently extracting, we would have already exceeded our carbon budget by 5 times for 1.5 degrees. And you can see on the left here is where we have a bunch of, for different points of warming, we have different carbon budgets. So we have, for a 66% chance of staying below 1.5 degrees, we have 6 years. For a 66% chance of staying below 2 degrees, we have 20 years, 20.9. So, yeah. Projections. 1.5 degrees is the goal of Paris. That's the goal of the Paris Agreement. That said, most countries are not abiding by that. 2 degrees, dangerous climate change. 3 to 7 degrees is where Paris pledges and targets gets us, which is obviously more than the goal of Paris. So even what we're pledging to is not enough. 3 degrees, the point of humanity not being able to feed itself. 4 degrees, certain parts of the planet become uninhabitable, and upwards of 3 to 6 feet of sea level rise. 1.1 to 3.5 degrees, what our current policies get us. So, our current 5 degrees, our current business as usual emissions, actually should be 4.2 degrees, is our current business as usual emissions trajectory. 6 degrees, that's human extinction. That's when all humans die off. And this isn't accounting for the runaway climate change thing, so you should be very careful. To have a 50% chance of staying below 1.5 degrees, a 50% chance, we need to reduce our emissions by 30% by, or 50% by 2030, and then net zero by 2050. But in reality, we need to reduce our emissions by 35% by 2025, 70% by 2030, and then net zero by 2040. The point is, the sooner we start lowering emissions and the faster we do it, the better. Some of this stuff is from an old PowerPoint, so I got a few things in here that need updated, and I didn't update them. So I just added some new slides, and I didn't really look at the old slides. So impacts for each projection. 1.5 degrees is dangerous climate change. At that point, almost all coral reefs will be gone. Hot days will increase by 16%. The average yearly drought length will increase by 2 months. That's all days without rain, I think. Maybe not all days without rain. That would be the average yearly drought length inclusion by 2 months. I'm not exactly sure. I guess it's consecutive days without rain. Reachable. That will be reachable by the 2040s. 2 degrees. 2 degrees. That's 2 degrees would be hurricanes intensity increases by 47%. 2 feet of sea level rise. Warming extremes increase by 343% over land. Hot days increase by 25%, and that's projected to happen by the 2060s to 2070s. Keeping track. So a no industrialized nation is on track to stay below 1.5 degrees. No industrialized nation is on track to stay below 1.5 degrees. Countries that are 2 degrees compatible: Philippines, India, Ethiopia, Kenya, and Costa Rica. Yes, India is. 1.5 degrees. The Gambia and Morocco are the only 2 countries that are compliant with that. Special mention, Norway. Norway would probably be the only industrialized country that would be able to meet 2 or 1.5 degrees Celsius if it didn't have its oil industry. So, carbon neutral countries. Oh, whoops, I put the wrong country there. The carbon neutral country is Bhutan, is a carbon neutral country. So that is really good. So they sequester all of their emissions. And that's everything. Thank you for listening to me. To recap, okay? We have about 6 years on our carbon budget. Okay, we have 6 years on our carbon budget. 6 years. Okay? We need to reduce emissions by 30%, by 35% by 2025, 70% by 2030, and a net zero by 2040, at least. There are tipping points and positive feedback loops climate system that could cause warming to get worse, and reinforce the warming that we're currently seeing. So that's everything. And remember, we need to reduce our emissions by 35% by 2025, 70% by 2030, and then net zero by 2040. And that's everything. Thank you for listening to me on this and fight for climate justice. Thank you for listening to me. See you next time.